Hello guys, welcome back to the yet another tutorial on the batch processing, and in this we are going to talk about the record block, not the record block, I'm sorry, the batch block size. Now before getting into the definition of what I have here right now, this guy we have to deal with the process. We'll get back to it later, but first let's as usual try to understand the small demo. I've created one small code here. Let me minimize this guy. This guy, and so what's this all about? So let's see that. A listener, which is of batch pro 04, you have this URL over here, cool. And then a transform message, and here I'm going to say a transform message of 1 to 5, a total of 6 records. Okay, so collection of records, we'll say collection of records, cool. Then you have a batch step, batch job, and here I've given a name as batch job 04, and I've given the batch block size as 3 instead of that. Yeah, let's do it as 3, or let me keep it as 100. Okay, initially let's keep it as 100 because by default the value will be always 100. See, let me show you this. If I drag and drop a batch job and click on this, see, by default it is 100. The batch block size, it's 100. I'm going to keep that as 100. Now collection of 1 to 5, and then 1 2 3 4 5, 1 2 3 4 5. I'll just make it a 6, that's better actually. 1 2 3 4 5 6, 1 to 6. So let's go back to this guy and we'll say record of 1. Okay, I'll tell you the reason behind this diagram. You will eventually understand the purpose of it. 2 3 4 5 6. Okay, let me make it all bold. I'll say 2 3 4 5 6. Okay, cool. Now then inside this I have added a batch step, and I'll accept policy as I'll do everything as all at this stage. Don't want to modify anything here. A logger slash n in batch 04, the payload. I'm just taking the payload, and here I'm saying, see, add payload plus 10. Add payload plus 10, and then I'll do one thing. I will add a wait time at the end of it. Okay, here there's another logger which is after transformation. So ideally what will happen after transformation? It will be after transformation it will be 10, 1 plus 10, that it is 11. Yeah, then you have 2 plus 10, that is 12, and so on. Okay, that is payload plus 10, and then the logger, the updated logger, and finally, you know what, I wanted to add one wait time. Wait, it's like you wait for some time before proceeding the next step, a wait time. So that can be done by importing. See, there's a thing called as a wait here. So this module can be imported by using this runtime. See, dw.runtime. In this module, there's a thing called as a wait. If I click on this, what it says here, is there any definition for wait? No. See, the wait takes the number, the value, and the number. The output is actually, it will wait for certain time. Say that now you have processed 5 out of 10 records. You have 5 records. It's you are dividing 5 records, like 5 records at one unit and 5 records as another unit. I'll say that process 5 records and wait for 1000 milliseconds. And after the waiting period is over, then you pick up the next 5 records. So it's like you're trying to put a pause in the system. So what I'm going to do, I'm going to put a pause here. Wait for, instead of 1000 milliseconds, I'm going to say wait for 5 seconds. Wait for 5 seconds. Okay, wait time. Now, yeah, with this being said, let's try to understand how this batch block actually works. It's a size of 100. Okay, let's run it. Let's debug it. and try to make a call. So while that is in progress, so here I'll take one and I'll say batch block size. Okay, I'll just do like this and I'll say batch block size. Guys, remember this is size. Size. Please understand the word. It is size. Batch block size. Okay, it's size. Okay, not how many blocks. There's a difference between how many blocks and the size. See, there's a difference between. Let's understand two questions. How many blocks? How many blocks? This is one question. And size of each block. Size of blocks. Are these two questions same? No. How many blocks have you addressed it? How many blocks? We don't know. How many blocks? No. But what is the size of block? Size of block is what we had kept here. Size of block is 100. Size of block is equal to 100. That is what we have kept. How many blocks is something that we need to figure it out. So the block size is equal to 100. We kept it at this stage. Okay, cool. Now how many blocks we'll address later. Now let us see how this works. Okay, cool. So let's hit it. So you got the first record 1 plus 10, 11. Then it will wait for 5 seconds and then it should pick up the next one. Or did I give too much of time window? Is it? What's the time window I had given? It's, oh, sorry, I have to give it as like this. I'm sorry. Okay, so let it get redeployed. Let it get redeployed. Okay. So already one has processed, so it's not going to process again. Okay, remember this. One has already processed, so it's not going to get processed again. Let it get deployed. Okay, okay. So I think that's a bummer. So it's fine. It's gone. It's yeah, it's just lost. Okay, let's try to re it again. So 1 plus 10, 11. Okay, and then see 2 plus 12. 2 plus 10, 12. See, it's every 5 seconds. So 0, 5, 10. Now it's 15. See here, which means every 5 seconds it is picking one record at a time. Did you guys understand that? It is picking up one record at a time. So 1 to 6, 16 every 5 seconds. So let's go back to this diagram and understand. Now we said that batch block size of 100, which means that it says we are size of 100. So totally how many size do we have here? Okay, totally how many records we have here? So records is equal to 6. Records is equal to 6, total of 6 records. And we are saying batch block size is 100, which means that if I say, okay, if I say records is equal to 6, if I say records is equal to 6, okay, let me add this here. If I say record is equal to 6 and batch block size is equal to 100, which means that 6 can fit within 100. Correct? 6 can fit within 100, which means you don't need to create multiple blocks. Just one block is enough, which means one block of size 100. Okay, in that 100 size, you have 1, 2, 3, 4, 5, 6, and you are still left with 94 records. So since there are 1 to 6 records, it is picking one record at a time. So it will pick one record at a time. One, then how it will happen? First it will pick up 1, then 2, after this 2. It's like 1, wait for 5 seconds, wait 5, and then 2, wait 5, and then you start 3. After 3 you wait 5, yeah, 3, wait 5, and so on. So what did we understand? So we have set a block size of 100. Size, guys, remember it's size. So you have 100. In that 100, you can definitely add 6 records. Correct? 6 records, which is 100 minus 6. How much? 94. You're still left with 94 size. So since the size itself is 100, it will create only one block. One block is more than enough to create it. Correct? One block is more than enough. one block can fit a size of 100. That's the reason it just picked up one record at a time. 1, 2, 3, 4, 1, 2, 3. Sequentially, one after the other. Now, let's do one thing. In the same example, I'll say record is equal to 6 and batch block size is 3. Now, I'll say batch block size is 3. Record is equal to 6 and batch block size is 3, which means let me take this out. Okay. Now, which means totally how many records I have? Totally 6 records. Okay. Can 6 fit in 3? Can 6 records fit in 3? No. So it will become one block of size 3 and another block of size 3. Second block. This is first block and this is second block of size 3. So that in the first block you will have 1, 2, 3. Okay. And in the second block you will have 4, 5, 6. Got it? Since the block size is 3 and the records are more, obviously 6 cannot fit in 3. So it's like you have 1, 2, 3. That's it. So 1 goes here, 2 goes here, and 3 goes here. Where does 4 go? Since 4 cannot go here, it will create another block. 1, 2, 3. Then 4 goes over here, 5 goes over here, and 6 goes over here. Cool? Now, question is that how will it process? Okay, now you understood it will create 2 block of 1, 2, 3. The question is that will it process like this? First 1, 2, 3 and then 4, 5, 6. Will it process 1, 2, 3 and then 4, 5, 6? Or it's like sequential, or it will process in different way. Let us check that. Okay, let us check how it works. Okay, clear? I'll change it to how much? 3. Save it. Okay, let it get deployed. Okay, let it get deployed. Was it deployed? Oh yeah, I think so. Ready? So question is that how will it process? Cool. Send. Now see, 1 and 4. It picked 1 and 4. Okay. Then it is waiting for 5 seconds. Then it is picked 2 and 5. Okay, that's odd. Then it's picked 3 and 6. Okay. Now that is very weird. Why it did not pick up? Question is that why it did not pick up 1, 2 and 3? Instead, it picked up 1 and 4. 1 and 4 became one group. 2 and 5 became another group. 3 and 6 became another group. Why? The reason is because, let me go back to the diagram. See here, it is actually picking up like this. See, 1 and 4, 2 and 5, 3 and 6. Which means first block is running in its own thread. Second block is running in its first block and second block. So there are 2 threads that I have created in parallel. So this is called as parallelism. So let us say T1, thread 1 and thread 2. Okay, let's see this. Okay, so ideally what is happening in the first block, it has picked up 1 and 4. This 2 have picked up in 1 unit. Okay, which means a total of, in one thread it has picked up 2 blocks which is in parallel, which means in this thread, okay, let's only take one thread at a time. Okay, thread 1. Okay, thread 1. So since 2 blocks are independent, right? So it picked up first value from here and second value from here. That's it. See, this is running in parallel. This is also running in parallel. And a single thread is holding that information. Of 2 blocks. So a thread, it has 2 blocks. Block 1 and second block. Both the blocks are different. Okay, both the blocks are different but running in parallel. See, parallel. So 1, 4 and then 2 comma 5 and then 3 comma 6. Got it? So now let me do one thing. Now instead of batch block size as 3, if I make it as 4, what will happen? Then here 1, 2, 3, 4 will be loaded, and here it will be 5 and 6. See, because the batch size block is 4, it can only accommodate 4 values, 1, 2, 3, 4. And here there's only 5 and 6. Since there's only 5 and 6, the second block will be created and it will accommodate. So when you run it, you will have something like this: 1 and 4, 1 and 5 grouped together, because 1 is here and 5 is here. So it's running in parallel. Okay, 1 and 5. Then 2 and 6. 2 and 6. After that, 3 and 4 will be sequential, one after the other, because the second block is completed and the first block will be running. Let's test that. Why to get confused? Okay, let's see this. What is the value? Size is 4. I'll do that size as 4. 4. Cool. Let us see. So ideally what will happen? This 2 will run together, 1 and 5. 2 and 6 will run together. So after this 1 and 5, it will wait. It will wait for 5 seconds. Wait 5 seconds. Let me color it up. And then this will wait for 5 seconds. And then after 3, it will wait for 5 seconds. And after 4, it will wait for 5 seconds. And then it will print the payload. Okay. So let's check it. See, 1 and 5 as discussed. See, 1 and 5. Cool, right? Then 2 and 6. See here, exactly 1 and 5 and 2 and 6. Can you see here? 1, 5, 2, 6, then 3. See, it is waiting for 5 seconds. Then after that, 4. See, 4. So let me bring this diagram. Okay, come on. Okay, cool. Okay, now if you can see here. Okay, I know it's too much short, and let me try to zoom in a little bit. Okay, that's better. See, 1 and 5 as one group and wait for 5 seconds. See, 1 and 5, they kicked off at the same time. See here, okay, 37, almost hardly milliseconds difference, and it waited for 5 seconds. So the next payload, it's like 2 and 6. Okay, 2 and 6, and then 3 and then 4. Okay, 3 and then 4. That's how the parallelism is achieved. So let's hit that again and see it. Okay, so see here, 1 and 5, 1, 2, 3, 4, 5. 2 and 4, 1, 2, 3, 4, 5. Next 3. Wait, 1, 2, 3, 4, 5. 4. See, difference 5 seconds, 5 seconds. See, 1 and 5, 39 and 39. See, and then you have 2 and 6, 39 and 39. So that's how it worked. Now you tell me. I'm going to give you another puzzle. Okay, cool. Now I'll do one thing. I'll give the batch block size as 5. Now what do you think it can happen? Think about it. So the batch block size is 5. First block, okay, first block will be 1, 2, 3, 4, 5. Second block would be just 6. Just 6. Okay, then how will it group together? Oh, okay. So I think I went too long. How will it group together? Think about it. So 1 and 6 will group together because it's running in parallel. 1 and 6, it will group together. Agreed? Okay. Then it will wait for 5. Then you have 2. Wait for 5. Then you have 3. Wait for 5. Then you have 4. Wait for 5. Then you have 5. Wait for 5. That's it. It does its job. So let's see this. I'm going to make it as 5. 5. Save it. And let's clear this out and see how it behaves. I hope you're understanding how this batch job is working at least at this stage now. Yeah. Then we still have to work on aggregator, guys. Okay, a lot of things. Okay, this batch job is a nightmare. Okay, so hit it. So here 1 and 6 as we said. Then wait for 5. Then you have 2, 1, 2, 3, 4, 5. You should get 3. Then 1, 2, 3, 4, 5. You should get 4. So you got the point. Okay, so it will run by its own. Not an issue. Then now is there a way? Let me do one thing. How about this? I'll make it as record as 10. Okay, so let's increase this. So 6, 7, 8, 9 and 10. 6, 7, 8, okay, 8, 9, 10. 10. And I will say records is equal to 6. And I'll say batch block size is 3. Now, what do you think it will happen? So, let me remove all those things. Okay. Now, what do you think it can happen? Think about it and give me your answer. So, we are saying batch block size is equal to 3, which means the first block would be 1, 2, 3. Correct? Second block would be 4, 9, 6. Okay. Third block would be 7, 8, 9. Agreed? 7, 8, 9. And my fourth block would be perfect 10. Now, how do you think it will run in parallel? The first the thread. Okay, so it will pick up 1, 4, 7, 10. Okay, it should pick up 1, 4, 7, 10. So 1, 4. Then you have 7. Then you have 7, and then you should pick up 10. Okay, it's 1, 4. Let me scroll a little bit here. 1, 4, 7, 10. Now that will wait for 5 seconds. Cool. That's done. 1, 4, 7, 10. Next, 2, 5, 8. 2, 5, and 8. Then wait for 5 seconds. Okay, it picked up 2, 5, 8. Then 3, 6, 9. Okay, then it should pick up 3, 6, 9. 3, 6, and 9. And then you wait for 10 seconds. Does this how it works? We don't know. Let's check it out. If this works, then our understanding is all perfect. So let's collection of records. I'll say 1 to 10. 1 to 10. And I said batch block size is 3. So 3. Okay. 3. Save it. Okay. So in the first run, you should have 1, 2, 3, 1, 4, 7, 10. Then 2, 5, 8. 1, 4, 7, 10, 2, 5, 8. Okay, let us check that. 1, 4, 7, 10, 2, 5, 8. Ready? Hit it. 1, 4, 7, 10. Guys, perfect. See? Next 2, 5, 8. See? Next is 2, 5, 8. And finally 3, 6, 9. 3, 6, 9. And it's done. Now question is that. Now question is actually, what is the question is that? How many threads can you go like this? This is 1, 2, 3, 4. 4 threads, right? 4 threads. Okay. 4 threads that are all running in parallel, because please understand, all 4 threads are running in parallel. This is of first block, correct? This is of first block. Okay. This is one thread. Okay. This is of second block. This is another thread. Okay. This is of third block. This is another thread. This is of another 10th. This is of fourth block. This is another thread. So totally 4 threads, T1, T2, T3, T4. 4 threads are running in parallel. I mean, like 4 threads have been allocated to do its job. So how many threads it can get allocated? Okay, how many threads can it get allocated? Now, if you have a Windows machine, what I want you to do is press Ctrl Alt Delete and click on Task Manager. And then what I want to do, go to Performance and see how many cores you have. 6. In 6. So multiply by that 2. 2 into 6, that is 12. So as per that, 12 threads can be allocated at a time. That's what I think the answer is, because when I hover across here, if I click on maximum concurrencies here, pause this and see. The maximum concurrency, the value determines the maximum level of parallelism that the job can use to optimize for performance when processing in blocks. If no value is provided, the default is twice the number of cores in the CPU, which means 12. Okay, which means 12, twice the number of cores in the CPU. At that stage, what will happen is that I'll remove this. I'll say 1, 4. I'll pick up 12. Okay, 3. Okay, this is one module. This is 3, 6, 9, 10, 11, 12. Okay, so it's like if I say 4, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, like this. Okay, so for this, we have to design one small test case from here. And how to do that? We will try to see if that works. If that 2 into twice the number of core CPU works or not, we have to check it. And to do that, tune into the next video. Until then, you have a great learning. Thank you.